Folks, it is 10:10, and so we are going to start with Data 8, lecture number 3. Announcements. Homework 1 is out. It does involve some material from today, but I think after today's lecture, you should be able to solve it. Please complete it by Thursday, but if you submit by Wednesday, you get a bonus point, and this is generally true. For homeworks and projects in this course, if you submit them a day early, you get some bonus credit, which is good. You don't have to solve all these alone. It's a good idea to try them alone, spend some time figuring it out, or talk to a friend, that's fine. Remember, don't share answers, but you're welcome to collaborate with ideas, just coaching people through how to do the homework. But we also have office hours. They're all online this week. We'll have some in person in the future. And this includes office hours for the staff. So there's office hours calendar. Go to data8.org/SB22. Here's the calendar, right? This has instructor office hours as well. Swapnil's will be today. Mine will be tomorrow. And the rest of them you can find on oh.data8.org. So the way this works is that you enter yourself into a queue and you'll be given a Zoom link when you're on that site for these staff office hours. So you don't know exactly who you're going to end up working with, but all the staff are really helpful and nice. So hopefully it'll work out for you. But if you want to talk to Swapnil in particular, you got to come to this hour. You got to want to talk to me in particular, you come to this hour. Otherwise, this is help from the staff in general. And you'll notice there's a concentration around the deadline for the homework. I'll also alert you to another part of the course. You already know about lecture, you've been to lab. There's also optional small group tutoring. This is groups of 4 and an instructor, a tutor for the course. And this is one of the best ways to learn. If you're going to spend an extra hour, like just learning about this course every week, you might as well do it in a small group where there's somebody there who knows the material really well and can help coach you and answer your questions. These tend to focus on conceptual review as opposed to just how to solve the homework. And the goal of tutoring is to make sure that when it comes time to take an exam, you know how to answer those questions. And that you can master the material so that when you go on to other courses, you have Data 8 concepts as a foundation. So I would recommend signing up for small group tutoring. Something like a third of the course will, and I think it's for everyone. It's a great way to spend an extra hour a week. I'm not going to force you into it. It's really up to you to decide how you want to learn, but you might as well use the resources that are available to you. These will start out in person, I believe, because they don't start up until next week. And fingers crossed, we'll be able to teach in person next week. We'll see. All right, I should look and see if there's any questions. Slides are on data8.org/SB22 in the big table. You'll find them there. How do you know whether your homework is completely correct? You don't. It's up to you to figure out the correct answer to the homework and submit what you believe are the correct answers. Then we will grade them, and then you'll get some score out of 100%, which may not be 100% if you got some things wrong. But if you think through the questions, you could probably get them right. How do you access lecture recordings? Again, those are on data8.org. So here's the slides. Here's the demos, and when there's a video, it shows up there. Right now for lecture 3, there's no video because we're making it right now. Small group tutoring signups are not out yet. Take a look on Ed. Would people with a good programming background benefit from small group tutoring? Yeah, definitely. I think that a lot of the challenging parts of this course are really around the statistical inference concepts, and tutoring spends a lot of time on those. We haven't gotten to many of them yet. You heard about a little bit of that from Swapnil on Friday, but there's quite a bit more to learn. So I would not say that tutoring is for people with no programming experience, although the tutoring sessions might be a little bit slow early on while we're focusing on programming in the very early part of the course. And attendance for lecture is not part of your grade. You could watch the video if you want, but it's really nice to have you here. And we have 1,000 people here, so that's really nice. I'm glad you're here. And what about room in tutoring sessions? Will there be enough room for everybody? We try. We have a fixed number of tutors. We don't know whether they're going to fill up or not, but we've made a good guess about how many people will sign up based on what's happened in past semesters. And what about tutoring? Once you've signed up, are you required to go? Yes. So it's one of those things where once you signed up, you have to keep going. Otherwise, you get dropped from tutoring. And how are the written responses for homework graded? Are there many correct answers? There may be multiple correct answers. They're graded by the tutors, which are part of the course staff. And we have a rubric, and you'll see how that all goes pretty soon. The homework one is not high stakes, right? It's just one homework. So I would suggest just doing your best, turn it in, see how it goes, and then you'll have a pretty good sense of how things flow in this course. But homework is not to test that you already know everything. It's really there as a formative or learning exercise so that you can master the course material. So I hope it doesn't cause a lot of stress, but does make you think a little bit. Okay, I did my best. I'm going to turn it over to Matthew to type some of the answers in Q&A, and I'm going to jump into the lecture. This week, we talk about Python, in particular, how to manipulate data tables in Python. Python's a programming language, which means that there are rules for how to form expressions in the language and what they mean. It's popular for both data science and general software development. It wasn't the original, like when Python was created, there wasn't really much data science going on in the world. And it was not designed as a language for data science. It just happened to have a very strong following already, and it was very extensible. And so it became one of the main languages for data science applications pretty quickly as this whole field developed. I think knowing the language means that you can communicate in it and get things done in it. And so learning a little bit of the programming languages fundamentals is critical. That's what we'll focus on. And it's hard to learn it through lecture. It's good to see some examples and learn the rules in lecture, but then you have to try out variants of the examples on your own. So that's why we provide you the demos. That's why we have lab, which you should definitely go to. And you might think, oh, I know Python already. Well, there's probably something you should learn. So please follow along with the course. Or you might think, oh my gosh, other people know this programming language and I don't. How could I possibly learn a whole language? Well, it turns out that even though we call this a language, it's not nearly as complicated as English or Chinese. Like you can learn it quickly. And we're not going to go through every single detail of it, just enough to make sure that you can work through all the examples in the course. So it's okay if you're learning this language from scratch today, but you will have to kind of pay attention and practice. And then you'll have to try out on your own, writing new code that solves new problems. So let's do a demo. I think I showed you last time. You can add, the theme of today is the number 8, because this is data 8, so you can multiply. But there's a lot of things that you can't do. Like you can't just write times 4, because that's not part of the language. And so we've gotten this thing that says syntax error. The syntax is the form of the language. And anytime you see syntax error, you've written some attempt at an expression that Python cannot understand. And so you have to just try again with something that it can understand. There's other ways that you can screw up. Here's a syntax error. But notice that my computer hasn't crashed or anything like that. I can just try again. I could even delete this and write something that is correct, like 2 times 4. Each time I'm running it by holding down Shift Return. But remember, you could press the Run button. I'm just doing a keyboard shortcut for that. And then your error goes away. So errors are not a big deal, except that they are something you have to address. The reason this is an error is that 2 has to be multiplied by something. It can't be multiplied by another multiplication. It just doesn't make sense in the Python language. So there are rigid rules. Python doesn't try to figure out what you meant. Instead, you have to follow the rules in order to express yourself. In fact, you can do that. And why did this work, but that didn't work? Well, it turns out that this is a totally different operator. It's the exponentiation operator. It just happens to look like 2 stars in a row. Why is it this way? Well, when they were inventing the Python language, they had to come up with some way of expressing exponentiation, and this is what they decided on, and it's stuck with it ever since. And so you just have to memorize this detail, that this means 2 to the 4th power, 2 times 2 times 2 times 2. This is totally illegal, and this is just regular old multiplication. There are other details about particular operators that you just have to memorize. Like when you divide, you get some decimal representation of 8 divided by 9. Lots of 8s, data 8. Okay, the quirk of division is that you're always going to get some decimal representation with a .0 after it every time you divide. That's just something you learn about the Python language. There's a reason for it, but in fact, the reason isn't so important as just remembering the fact. Okay, so this is something you've learned today, is that when you divide, you get a decimal representation as opposed to an integer. But some things are quite intuitive, like the precedence rules that you learned in algebra, which is that you multiply before you add, apply here. If you want to use parentheses in order to change the order of operations, you can do that. If you want to negate something, you just put a minus sign in front of it. In fact, you can negate a whole expression like that. So we added 1 and 1 together, we negated it. We could extend this if we want, 2 times 3 times 4 times 5 divided by 6, whatever. Just like add stuff together in some complicated expression, and Python's going to evaluate it for you. 2022. Okay. The last thing I wanted to share was that what we're doing here is writing down expressions in cells in a notebook. What you see down here is the value of the expression. And there are different kinds of values. So far, we've seen numbers, 2 kinds of numbers. There's integers. There's this decimal representation, which is called a float. We'll talk about that a lot on Wednesday. There are other kinds of values, like you can represent not just numbers, but also text. This is called a string in programming languages. This is not a Python specific term, but a general term, a string. So the whole point is that you could have an expression that doesn't build up a number. Instead, it just builds up some text. Quick review. An expression evaluates to a value. Values can be numbers or strings. We'll see lots of other kinds of values too, like tables we're going to see in this lecture. And the format or syntax of the language is very rigid. So even an extra space sometimes can cause a syntax error. You have to just get used to this fact. And there's a particular behavior associated with built-in operators. So how does the star star work? It exponentiates. How does dividing work? Well, it produces 8.0 instead of 8. These are just things you have to learn about the programming language, and they're not that hard to learn if you just practice with it a little bit. Okay, I see a pile of questions. Let's take a look. Is it frozen for everyone? I sure hope not. If I've been talking and no one can hear me, well, there's some questions about what I said, so I think maybe we're okay. Are operators also expressions? That's a great question. They're not. An operator itself doesn't have a value, and we could figure that out just by trying to figure out the value of this operator. And we'll say, no, you can't do that. So it's not a full expression because it can't be evaluated on its own. A string is just a line of text, that's right. And what about single quotes or double quotes? You can use either. I won't talk about the difference between them at the moment because it so rarely matters that you don't really need to know. And string is just text in general. Yeah, that's right. Well, I've answered a bunch of these live. I should mark them off. And there's a question about printing. We'll get there in just a second. That's a great question. What about printing? We'll get there pretty close. And does having a decimal like 10.0 change things? It does. We're going to dive deep into this decimal representation business on Wednesday. So far, I just wanted to let you know that that exists. Okay, I got through most of the Q&A. I see there's a huge pile of chat, but I'm mostly looking at the Q&A. So if you want to get me to answer a question, you should be putting it in the Q&A, not the chat. The chat is for you all to complain about the Wi-Fi. And I'm sorry if it's lagging. Hopefully the recording will work if things wipe out on you. All righty. back to lecture. Names are really important. There's a type of statement called an assignment statement that gives a value to a name, and you can make up new names to refer to values. The reason you want to do this is it helps you organize the programs that you write. Names are pretty useful in the real world too. Like if you didn't know what to call me, then you'd have to come up with some long description, but it's easy. You just call me John or De Niro or whatever you call me. That name is a useful part of the English language. Well, it's useful in Python as well. An assignment statement looks like this. It uses this built-in equals operator in order to do something. What it does is it assigns a value to the name on the left. So you have a name on the left, any expression you want on the right. An assignment statement changes the meaning of the name to the left of the equal symbol. This one that says hours per week. And the name is bound to the value of the expression to the right of the equal symbol. So multiply 24 times 7, get the value. Now that's bound to hours per week. These names can be anything you want, except they can't have spaces in them, which is why it's very common to use this underscore character in order to kind of look like a space, because you're not allowed to have a space. One of those rigid rules of Python. And it's got to start with a letter, but it can actually have numbers in it as long as it starts with a letter. So let's talk about assignment statements and names. When I write a equals 2, a is the name, 2 is a very simple expression that gives me a value. Notice something interesting happened, which is that I evaluated this and nothing showed up below it. No syntax error, no value. An assignment statement does something. It changes Python's memory to now know that a is equal to 2, which means that if I do something with a, the value 2 will be what a evaluates to. So this finds out a is 2, I add 1, I get 3. You could even evaluate a directly. That's an expression in Python that evaluates to 2. And why 2? Because I said it that way. If I tried b, it wouldn't work. I'd get an error that says b is not defined. But I could define b just by using an assignment statement. And then I can write down anything I want. Now here, I've put multiple lines in the same cell. Very common thing to do. What Python does is it goes through and it evaluates each of the lines. And then it shows you the value of the last one. Is b 6? No, b is actually just 3 because we set it to be 3. Is a 6? No, a is just 2 because we set it to be 2. A times b is 6. And so I wrote this in order to set b to 3 and then figure out what the value is of a times b and have that be displayed. A very common pattern is that you'll write some assignment statement and then you'll write the name that you just assigned. And the reason you do that is so that its value appears here. So that not only does Python memorize the total is a plus b, but also you as the human using the notebook can see what the value is. Total is bound to the number 5, even though it was created using an expression that says a plus b. As a result, if I now assign a to 10, a is 10, total is still 5. This confuses people all the time, and rightly so. Shouldn't total automatically update because we changed a and total is supposed to be a plus b? Shouldn't total be 13 now? You might think so, but the way Python works is that each operation is just very simple. Assignment takes the value of this thing at that moment when it was evaluated and assigns it to the name total. And then it doesn't change total later. It's not like a spreadsheet where everything is connected. You can create that behavior by writing a long program, but the fundamentals of the language are much simpler than that. They just assign the name to the value, and it's up to you to make sure that total gets updated when it's time to change a. So if I wanted a to be 10, and then I wanted total to be 10 plus 3, then I would have to execute this again. Okay. Now I'm going to show you something pretty tricky about notebooks. A notebook, at some point, you might decide, I want to start over. I want to forget that A and B exist. You can do that by writing restart kernel and clear all outputs. So all the code that I wrote is still there, but Python's starting from scratch. A doesn't exist. If I type A here, I'll get a name error. So then I can start over and start working through my examples. A is now 2, A plus 1 is 3, A is 2, B doesn't exist, but now it does. B and A are there. Total is 5, A is 10, total's still 5. One thing you have to be aware of in notebooks is that it is possible to evaluate cells out of order. And Python just accumulates information based on the cells that you evaluate. And so if I go back and evaluate this cell again, now I'll get a different answer for total. It reevaluated what it thought A was, which is 10, and B was, which was 3, and got a total. Notice that nowhere above this did it say A was 10. The only thing that is kind of a clue that things happened out of order is that we evaluated this as the 10th thing, so A was 10, then this is the 11th thing, then this is the 12th thing. So if you look at these numbers over here, they tell you the order in which things were evaluated, and they show that this was never evaluated at all. So total is not 1 because I never ran this cell. So if I run this cell, then total is still 13. If I then go back and run this cell again, then total is 1. So you just have to be aware that Python is accumulating information based on each cell that you decide to run, but you can decide to run them out of order, but don't do that. Totally confusing to everybody, including yourself. So try to just run them in order. Sometimes you want to go back and tweak things like, oh, I really wish this was 12. So you might run them out of order for that reason. But you do have to be careful because running them out of order can confuse yourself. And so one thing you can do is always just restart, clear all outputs, run things in order again, and then you can be back in business. I will show you one other trick about running things multiple times, which is that you could, in fact, take A, which is 10, and then assign A to be A plus 1 and see what A is now. Okay, A was 10, so now it's 11. But if I run this cell again, now A is 12. And now A is 13. And now A is 14. And now A is 15. Now A is 16. Like the value of A depends on how many times I ran the cell. That code isn't anywhere on the screen. And so even though you're allowed to do this, I strongly discourage you from doing it. Instead, it's better to write code that you can read so that you understand how the values came about. Okay, so now you know some of the gotchas of this notebook-based computing environment, and you know something about how assignment works, which is that you evaluate what's to the right of the equals, you assign it to the name on the left. Now that name on the left has that value, but it's not bound to that equation, it's just bound to the value that resulted from evaluating that equation at the time that you ran the cell. A little bit of Q&A. Could you reassign A? I think we answered that. Yes, you can. Reassigning A means you forgot the old value of A. Now you have a new value of A. And there was an interesting question, which is for an assignment statement, how come it doesn't just show you the value of the name you just assigned automatically? Why do you have to type out total equals A plus B and then total? That's just a rule. That's how Python works, is that when you have an assignment statement, that statement itself doesn't have a value. You then have to write an expression, just the word total, in order to get the value. It's a quirky rule. Could be different. Different programming languages actually do it different ways. But this is how Python works. There was a question about what I did in the kernel tab. I did something really tricky there, didn't I? In the kernel tab, anything that says restart kernel is going to start with a fresh memory. In Python, it's called an environment. So a fresh environment where A is not defined anymore and B is not. All these options will work. And I would strongly encourage you, if you didn't figure out like why total ended up the way it was at a particular moment, that you just try this out. Like go get the demos and mess around for a while. Try doing things out of order until you get a handle on exactly what's going on. Okay, and how did I get the notebook to forget all the names? I restarted the kernel. The kernel is the Python programming interpreter that keeps track of where you are. Whew. Functions. Just like you learned in algebra class, you can write a function call expression in Python. So if f is a function and you want to call it on the number 27, you write this. This is the function you want to call. This is what the argument, we call it, the thing you want to call it on. And the right way to think about functions is that what's in parentheses is the input, and then the value of this whole expression f of 27 is the output. So you could read this as call f on 27. And there are built-in functions. So f is not built in. We're going to have to define f. We'll do that later. But there are a bunch of built-in functions like the max function or the absolute value function. And some of them take multiple arguments. So you can say, what's the max of 15 and 27? And this would tell you, oh, 27, because it's the biggest thing that you passed in. Well, I skipped this part. Well, it's okay. I'll go back if I have time, but I don't have time. So we'll just let it go. Okay, functions. Absolute value. It's built in. So you can just type abs and it will tell you absolute value of -4 is 4. The absolute value of 8 is 8. You can write any expression you want in here. And it will first evaluate this and then figure out what its absolute value is. So now you know about the built-in absolute value function, but there's a bunch of other functions. I will say that you can use these in combination with, came back, with assignment statements. So if I wanted, actually, I think the high today is 58 and it's like 42. If I wanted to know what the temperature difference is going to be in Berkeley, I could give these things names and then compute the absolute value of the difference between them to see how much change in temperature there will be. I mentioned max, so max of 2 and -3 and 4 is just whatever's the largest number among them. Why would you ever do this? Like you look at it and you can see it's the number 4. The idea is that if you've already done a bunch of computation and instead you have names for things like the growth rate of the temperature of the United States over the last 3 years and the rise in sea level or something like that. So you have like 2 different names and you didn't know in advance what the values would be because you had to do a lot of computation. Then you use the max function to figure out which one's bigger. So because it can be used in conjunction with names and those names can have their values built up over time, it's useful to have these primitive operations in order to combine values together. How do you take the square root of something? Well, you type square root. What's the square root of 4? It should be 2. Well, actually, we got a name error that says square root is not defined. That's because square root is not built in. Instead, it's part of a built-in module called math. And the way you access that is to import math. You have to run this cell. Now you can refer to a bunch of different mathematical functions that are built in. Why do I have to write math.square root? Well, because it's part of math. And there's a bunch of other math that's available. If I type math dot and then I press the tab key, the notebook environment will show me all of the different ways that I can complete this function name. So you can take the r cosine, the ceiling, the cosine, blah, blah, blah. There's like a bunch of different mathematical operations that you can perform, including the square root. So if I type s, then I see all the ones that have an s in them. And pretty soon I'm down to the square root. And so then that's an easy way to see what's available to you and try stuff out. Another important built-in function is the round function. Which rounds to the nearest integer. Unless you want it to round in a different way. What's interesting about round is that it has an optional second argument. Where I could say, I want 1 position after the decimal point, and it will round to whatever's the nearest 10th. So there's 2 ways to call round. You pass in the number you want to round, or you pass in the number you want to round and how much you want to round it. Now I'm going to show you something that often confuses students. So pay close attention and then ask some questions. Instead of writing it this way, I can actually write n digits equals 1. This is not an assignment statement. N digits is not defined. Instead, this is a way of calling round that passes in an argument which is named. It's just a way of naming the arguments so that anyone who reads this expression can understand what this 1 is doing. Oh, it's rounding to the nearest, it's telling you the number of digits after the dot. Now, how did I know that n digits was the right way to write this? Well, I have to look at the documentation for round. I look at the documentation by putting a question mark after the name. I could have done this for square root as well. What's special about round is that it can take 1 argument or 2 arguments. This equals none basically says you could leave it out. But this gives you the names. And these are the only names you're allowed to do. So you are allowed to write round number equals 12.34. That's okay. But if you write round, I don't think it's number, I think it's n, you're going to get an error. You have to use the names from the documentation. So if at any point you see a call expression where within the parentheses you see a name and then an equals, what it's referring to is one of the argument names for a function. And there's more to a function than just its name. There's also its whole documentation, which describes what it does, which includes names for the arguments, and you're allowed to include those names. Cool. Some arguments require a particular number. Some functions require a particular number of arguments. So abs always takes 1. Round can take 1 or 2. You can name the arguments in the call expression, but the names must match the documentation, and the question mark lets you see the documentation. Okay. A little bit of Q&A. There was a question about when you're writing a call expression, can you put more complicated expression in here? And yes, definitely. So I could say I want to run 8/9 to 4 digits, and we'll do that. So you don't have to write just a number here. You can write an arbitrarily complicated expression, which can include names and numbers and arithmetic, anything you want. In fact, you could even include calls to other functions in there. For max, what does it do? Does it tell you the biggest number in between the interval of numbers? No, actually, it just chooses the biggest number. It just chooses the biggest argument. That's what max does. It takes in a bunch of arguments, tells you which one was biggest. Go over how to find the biggest absolute difference. I think I'll leave that for Matthew to answer. Some discussions of homework. Does the square root function return a decimal always? Yes, much like dividing. When you take the square root, you always get this 0.0, even if the result should be an integer. And how do you see the math operations again? I'll end with that. You type math, you hit dot, then you hit tab, the tab button on your keyboard, and then you'll see all the options. What other modules in Python will be useful in this class? Well, I'm about to tell you about a new one called data science. But first, let's do a little preamble. A lot of data science works with tabular data. We're going to spend quite a bit of time in this course on that. If you come out of this course being an expert at working with tabular data, you have improved your ability to work in data science by quite a bit. A table is a sequence of labeled columns. Those labels are names for the columns. So a column has some description associated with it, whereas a row does not. Rows are the individuals, maybe the individuals in an experiment. And what's the difference between a row and a column is that rows don't have labels. They don't have names. Data within a column represents one attribute of the individual. So you have different rows for different people, and you might have as one of their attributes, their hair color is a string, or their number of teeth, or something like that. Here's an example where the individuals are not people, but instead states. Here we write out the table in some sort of like generic fashion, where the bold at the top is supposed to be the label. So there's really only 2 rows in this table, 2 rows of data, one about California, one about Nevada, and there's 3 columns, the name, the code, and the area of the state. Working with tables is essential to getting anything done in data science. And in this course, we're going to use a module, not the math module, but the data science module in order to work with tables. What's special about the data science module is that it has table. It's like a kind of thing built in. So now you can make tables. Data science was created for this class. I wrote the first version. I've had a lot of help in refining it. It's used broadly for teaching data science. It's only used a little bit in industry, and it's mostly students who took this class and then went and like got an internship and started using it because it's what they knew. It's a teaching module. It's not really an industrial strength module, but it's very similar to the industry standard module that is used, which is called Pandas. You'll learn about that in Data 100 if you take that course. You have to know a ton about Python in order to learn Pandas. What you need to know about Python in order to learn the data science module is much less. You need to know what I told you: assignment, arithmetic, function calls, and then you're ready to get something done. And so that's why we use it, is so that we don't rely so much on prior programming experience, but instead let you dive into the interesting part, which is how you manipulate tables themselves. So you're going to need to learn the details of the table type, which is part of the data science module. And how come it was never referenced here? Well, star just means import everything from the data science module. So once we do this, we can refer to tables. You can write, what I want to do is read the table. So this is like math.square root, table.read table, tells you what kind of thing you're working with, and then what you want to actually do. So here's the function name. And what we're doing is reading in data from a file, and it's about ice cream cones. This is the most boring table we'll see in the whole course, but it shows you that within a column, you can have the same value repeated twice. Here's a column of strings. It can be the case that a whole row is repeated. There's nothing that's a constraint about tables that says everything has to be unique. And there can be columns of strings, and there can also be columns of numbers, and you can mix those together. So here we have 6 different buckets of ice cream in an ice cream shop, and they happen to have 2 different dark chocolate buckets that have the same price. They've got a milk chocolate bucket that's a little bit cheaper, some strawberry. They have some, cheap strawberries, some expensive strawberry. You can write anything you want in a table, and you shouldn't make assumptions that every line is going to be unique, or that every flavor is only going to appear once when you're working with a table, because that might not be true. You could check that, and once it's true, you could use that assumption. But beforehand, there's no constraints on what can be in a table. The goal today is to tell you a little bit about manipulating tables. Oh, we've got time to do it. Sometimes a table has so many rows that you only want to see the top few. The show method of a table allows you to do that. Notice what I've done. I've used the name of the table that already existed. Cones is this table. I've then put a dot, which says I'm going to do something with the cones table. Show is something I'm allowed to do to a table. So I can do it to the cones table. I can show 3 rows. And here I've written down an argument 3 to say how many rows there are. If I want to know how cones.show works, I could put a question there. And it says this displays the table, and you can pass in the max rows. All right. Notice the whole table's there. It says 3 rows omitted. And in fact, this didn't change the table. It just showed me 3 of the rows. Okay, more interesting stuff that you can do with the table is you can show only some of the columns. But remember, columns have labels. And so if I just want to see the flavors, then I would write flavor. The gotcha that trips students up is why this is in quotation marks. In quotation marks, this is just some text. Notice that I never assigned flavor to anything. So if I type in flavor, I'll get a name error. So for this reason, it's not okay to select flavor because flavor doesn't refer to anything. This would give me an error, the same error that I would get if I typed flavor on its own. Instead, what I'm doing here is saying, hey, cones table, please select the column with the label flavor, where flavor is a string, some text that is the label of some column. And yeah, it only works if this is actually a column. So if you write it wrong, you can run into trouble. You get this long error message. Every time you see one of these, you might want to just walk away. But instead, ignore most of it, look at the bottom, and see what it says. The column flavor is not in the table. You can only use flavor, color, and price. And you say, I did use flavor. Oh, but I forgot to capitalize. So it is really particular. That's how programming languages are. Okay. What if you want 2 columns? Well, you could select both flavor and price. Assuming we actually type out select. There's another way to get the same table, which is to, instead of selecting flavor and price, we could drop the color. So what drop does is it selects all of the columns except for the ones that you name according to the label. So now you know how to get subsets of columns. The whole table's still there. If what I really wanted to do was first drop the color and then do something, I would have to use a new name. So now cones no color has no color column. Cones does, in case I want to go back and use that. But isn't it convenient that now I could take cones no color and show just the first 3 rows or something like that. And it has retained this characteristic that it has no color column because I used assignment in order to capture the result of dropping the color column. Goodness. We're almost to the interesting table, but I want to show you the main event. 2 methods, which are ways of manipulating tables, that you're going to use a ton in life and in this course. One is to select particular rows. Instead of using select, which selects particular columns, you write where, and then you have to give some criterion. Like I want the flavor to be strawberry. What I get is the whole table with only the rows that have strawberry as their flavor. The other one I wanted to show you is that you can sort. You can sort by price, This will give you the price in increasing order. You could sort by price in decreasing order by adding a second optional argument that says descending equals true. True is a value that is, the opposite of false. And yeah, once you can select particular rows, particular columns, and sort things, you can pretty much take an original table that's full of stuff and get you down to the part that you actually care about. So let's do an example of that with some real data. Here I have a table with 9,456 rows. I can only see 10 of them right now. That's the default. Somebody put this together. Thank you to them. And what it shows is the salary of different NBA players in particular seasons. The columns are the rank within that season of how much they were paid. So Shaquille O'Neal was the highest paid player in 2000, played for the Lakers, played center, power forward, shooting forward. It's probably something else. What is SF? Someone will tell me in the chat. Point guard is PG. And yeah. So these are the positions they play in the game of basketball, which obviously I watch a lot of since I don't even know the position. Okay, and the team, salary in dollars, the season. What if you wanted to create a table with just the point guards, that's the PGs, in the 2020 season? How would you do that? Think about it for a second. What expression would you write? Small forward, thank you. Small forwards aren't always that small, right? It's kind of a funny name. How would we do this? Well, this is just point guards and just in the 2020 season, which means we need to assert two different criteria. NBA where position is point guard. Gets me partway there, but still I have the 2000 season and the 2001 season and all of that. On a separate line, I write NBA where season is 2022. Oh, sorry, 2020. I think that's as far as this data goes. Now I have point guards, but I also have small forwards and shooting guards. So how do I combine them? Well, you take the result of filtering for only the point guards and filter it further. Now I have all the point guards for the 2020 season. Maybe I'll give that a name. And then I can, look at it. I could even show you the whole thing. Pretty long. I could sort it by the salary. And we learned something interesting, which is it was already sorted in descending order by the salary. And Steph Curry was the highest paid point guard in the league. Well, it turns out the lowest paid point guard in the league also plays for the Golden State Warriors. It doesn't get quite as much playing time as Steph Curry. So that brings us to 11 o'clock. I know that I didn't answer all of your questions, and I'm sorry for that, but we'll pick this up on Wednesday and keep learning all about tables. I'm going to leave you with just a quick slide which says, here's what you were meant to learn today. That you can select, you can drop, you can sort, and you can filter to have some rows. And there's a little bit more to learn about each of these operations, so we're going to practice them throughout the week. But now you have some idea of how you can start with a table and apply multiple operations to get the table that you want. Okay, see you Wednesday.